Hey everyone, and welcome to the next live video session by Quant Masters on the TCS digital questions that you can expect. Now, TCS digital are there on 20th, that is tomorrow as well, and you can expect a lot of questions, particularly on things like greedy method, dynamic programming, and so on. So, today we will look at one program that is based on the concept of dynamic programming. So this question can be solved in many ways, but if you solve it in any way apart from dynamic programming, you will expect an error called memory limit exceeded error. So to ensure that memory limit exceeded or time limit exceeded error does not happen, to solve the program I'm about to take up, you need to do it using the concept of dynamic programming. So, first I'll give you the question and I'll also explain what exactly is dynamic programming within a minute, and we'll try to solve this question. And if you're able to understand and analyze this particular question, you can solve at least 10 to 20 different number-based programs similarly by yourself. So our aim is to make sure that you can solve this question, and if any similar question is also given, you can even solve them. So I'll just take a minute to explain what dynamic programming is. Think about this. If you want to find nth Fibonacci number, you need to get all Fibonacci number before it. If you want to find fifth Fibonacci number, you need to find 1, 2, 3 and so on, all of this. The problem is the way we learn it. In our first semester generally, the way we learn it in labs is the worst possible method in terms of time efficiency. I'm talking about in terms of time efficiency and space efficiency, not necessarily space, mainly from a time efficiency perspective. We learn the worst possible method. I'll explain how. If you want to calculate sixth Fibonacci number, what we do is first calculate Fibonacci of 5 plus Fibonacci of 4. To calculate fifth Fibonacci number, you're calculating Fibonacci of 4 plus Fibonacci of 3. To calculate this fourth again, you're trying again as Fibonacci of 4 plus Fibonacci of 3. Now to calculate this, you're again going to keep splitting. Now if you observe here, you're calculating, one small mistake, Fibonacci of 3 plus Fibonacci of 2. Now if you observe, you're calculating fourth Fibonacci number twice. Whether you calculate here or here, result is same. Result will not change. Then why are we supposed to calculate it twice? Dynamic programming is the solution to ensure that whatever work you are doing, whatever calculations you are doing, you are never supposed to do same calculation more than one time in your program. Here, for example, if you want to calculate Fibonacci of third Fibonacci number, you're calculating here. You're also calculating here. This is the recursive method we learn. To avoid all of this, what we can do is have an array. We'll have an array by stating which is the first Fibonacci number, second, third, fourth, and fifth. All that we're going to do in the array is store first two values as 0 and 1. To find third value, we'll add them. That is, f of 3 will be f of 2 plus 1. That will be 1. Then to find the next value, we'll add the previous 2, let's say 2. To find the next value, we'll add previous 2, let's say 3. How many steps did we do here? We calculated this only once. We calculated this only once. We calculated this also only once. In recursive method, we are calculating these multiple times, even the rest. So I'm just taking this one example. I was supposed to take Fibonacci of 0 also in index, but I just took this one example only for us to work through and understand this. So by this, we can understand that we are not supposed to solve anything more than once, greater than one time. So whatever you need to solve, you should only write a program which is able to solve it one time only at maximum. That is the solution. So the question now, let's go on to the question part. What exactly is the question that you may expect? Your question will be something like this. You will get an array of numbers. I'll just take this. we'll just write an array of numbers here. I'll just take some random values just to explain now. And when we go for the program, I'll change this slightly. So I'll just write some indices. And we'll just write some numbers. Let's say 1, 2, 0, let's say 3, 0, and let's just call 7 or something like that. Now, here's the question. The question comes up like this. Find whether you can jump from first index to last index. This is the question. Find whether you can jump from first index to last index. There are some criteria. There are some conditions that will give you. So you need to find whether you can jump from first number to last number. That's the first part. And second part, you need to find how many jumps do you need to go from first digit or first number to last number. What this means is, if 1 is there as the value in index 0, I'll repeat, in index 0, if the value is 1, that means you can make jump up to one more index. You can make jump up to the next index, which is 1. Up to next index. Maximum you can make one index jump. In 1, similarly, you have 2. That means from 1, you can jump up to 2 indices at maximum. Similarly, at maximum means you can also jump to 2 if you want. That's up to you. That is your choice. So you can jump from 1 up to 2 also. You can jump from 1 up to 3 also. So followed by this, from 2, since it's 0, you cannot jump anywhere. You can't jump ahead whatsoever. From 3, you can jump 3 values maximum. There are only 2 values ahead, so no point in having 3. We can jump from index 3 to both of these values, because we can jump 3 values ahead. From 4, the value here is 0. You can't jump anywhere. From 5, you can jump 7 values ahead, up to 7 values ahead if there were 7 values ahead. Now the question comes up as, calculate the minimum number of jumps required to reach the last index of the array from the first index of the array. This is the question. You need to calculate the minimum number of jumps required to reach last index of the array from first index of the array. Let's try doing this manually first, just to understand whether we can jump from first index to last index directly. So from first index, where can I jump? I can only jump 1, because the value is 1. I can only jump up to one value, one index. So from 1 I can jump 0. From index 0 I can jump up to 1. Done. From index 1, where can I jump up to? I can jump to 2 or 3. So 0 to 1, this is first jump. First jump is compulsory. From 0, wherever you have to do, you have to jump. First jump is compulsory. After first jump, I can go up to 2. Does it make sense to go to 0? It doesn't. It doesn't make sense to go to 0. But it makes sense to go to 3, or this value, this index. It does not make sense to go to index 2, because you can't jump anywhere. Then you won't get minimum number of jumps. So what we do is we directly go on to 3. Here we have a value. Now from here we can jump up to 3 values, whereas that means we can directly go here. So 1 jump, 2 jumps, 3 jumps. 3 is the minimum number of jumps we require. Now if there was another number here, like for example, instead of 0, let's take 1. Now if you do something like this, from here to here, from here to here, because it can jump up to 2 values. From here you can jump up to 3 values. If you go here, from here you can go up to 1 value. You go here, then it's no longer perfect, because from here you're not having minimum number of jumps. So this is the basic question. So I'll write the question here so that I can share it to you later on as well. So calculate the minimum number of jumps required to go from index 0 of the array to the last index of the array. Now the condition is each index of the array stores a number which is the maximum number of elements or maximum number of nodes that can be jumped either to left or to right from that index. So each index consists of a value. That value indicates how many values, how many indices can you jump at maximum either to left or right. So 0 has an index 1, so I can jump one index to either left or right. So this is the whole idea. So let us try this out. Let us start solving this and let us figure out how we can solve this. So first thing, to do this, let me take a simple example over here. Let's take I'll just take one sample example that was previously tried with. This same example we'll try even in our program. We'll take 1, 3, 8, 1, 0 and 6. Let's say we take this. Now, if you observe here, from 1 I can go up to either only 1. From index 0 I can go only one value, that is up to 3. From index 3 I can go up to either 8, 1 or 0. Now generally I'll state this, when we go for recursive method, what are we going to do? We're going to try every method. This is also called naive approach. This is what gives you the error, that is either memory limit exceeded error or time limit exceeded error. From 1, that is from index 0, since I have only 1 as the value here, I can go one value ahead. So when I go one value ahead, now I will try all conditions. Since I can go 3, I will go 3 also, I'll go 2 also, 2 values ahead, I'll go 1 value ahead also. I'll try all. From 3 I'll see if I can go ahead. No. So I'll go to 2. From here I can see if I'll go ahead. No. So I'll go here. From here I'll see if I can go ahead. I'll try all possibilities. This is a smaller example, but when we take a larger example, all possibilities will take a lot more time. So that is going to give us a problem when we are executing this program in the interview. So let us try to solve it in the easiest way possible. So I'll also give you what will be the input and what should be the output. Your input will be first an integer n, that is the number of elements in the array. This is followed by n integer elements of the array. Your output will be number of steps required to reach last index. If you cannot reach last index, 0 otherwise. That means if you cannot reach last index, then you have to print 0. To give an example of that, let's say this is 0. If this is also 0, I have 1, I can go only one value. Here I have 3. I can go either here to index 2, to index 3 or index 4. If I go to index 2, I can't move. If I go to index 4, I can't move. So no point in this. If I go to index 3, I'll move to index 4, from where I can't move again. So no point in even this. So I can't move to the final index at all. That is why we get to print 0 as the output. This is our program. So sounds simple enough. Now we're going to solve it using dynamic programming. Let's take a sample input. The sample input here is 130106. So I'll give 6 as the input, that is 6 numbers. Then the values entered will be 130106. So the output, sample output, according to this, should be 0 because we cannot reach the last index. So let us try creating this program. So the way we're going to create it is through C programming. So let us give this a try. Let's start from the basics of it. Now, first thing, we need to enter the data. The first thing is we need to enter the data so that we can store it and then start calculating. So let's start with the C program. We'll use hash include stdio.h. We need this for printf and scanf. We'll create a main program. And apart from main program, if you want, you can create one more program called min jump calculate, or you can call it anything like something like void, or you can return int because it's supposed to return an integer value. You can return int, or if you want, you can also make it void and have you print the same function in this. That's up to you. We'll make it void for now. It can be done either way, up to us. So find min jumps of a function. This is what we are writing. Now let us read the input. Now I will not start with the coding directly. I will explain the algorithm. I'll explain the logic. Only after the logic we'll go for coding. So let's start with the logic here. Before logic, I'll just read at least the input and show you this much part of it. So we need to read a couple of inputs. There is n, and we need to also read an array of n elements. To read an array of n elements dynamically, I'm going to use standard library.h. If you want to know more about this, you can visit one of our previous videos. Standard library.h or standard library header file is used to dynamically allocate memory in your program. So we will allocate memory dynamically for our program here as well. That is, once we read the number, again, please do not use any printfs or any other statements, because you're only supposed to print output according to this program. According to this program, sample output should only be number and nothing else. So that is what we're going to do. %d, sorry, comma, %n. Now once we have read this, we'll now create an array which of n elements. To store an array, we use a pointer variable. To know more about this, if you're new to this, you can watch our previous videos as well to get to know in detail about how exactly this works. So now let's take this up. We'll create in this array, we will take malloc of size of int into n. So however many, see, you need n elements. Each element takes size of integer. So each element takes the size of integer, and you need n elements. So that is result, whatever we are getting, we are storing it in p. Generally malloc returns void pointer, will convert it to int pointer. So p is now our array. We can use it as required. This is our input. Now we need to send it to find min jumps to calculate. Now first thing I'm going to do is go back and start learning how to solve this. Now we'll take the previous example 138106 and let us try figuring out how to get the output of this with dynamic programming. Now this is where you need to understand and observe very carefully, because if you observe and understand this part of the program, everything else becomes very easy. And this is how you can also learn how dynamic programming works in this example as well. Now let's start with this. If I want to find out all of this, I'm going to create another table. I will create one more table where I will store all the jump details, that is, from where I can jump to where, in short. So what I'm going to do here is create one more table with the same length. We'll create one more array here which has the same length as our input array. So let's create that quickly. All right, so now all these indices will be 0. All these values will be 0 initially. The indices will not have any value whatsoever. So this question can be asked in many ways. Ways this particular question can be asked. Now, the first thing you need to know to perform this, let's call this as something like this is our input array. This is our input array. This is called minimum jump array. what it will store here is, to reach index 1, how many jumps do you need minimum? From there we will calculate to reach index 2, how many jumps we need minimum. From there we'll calculate to reach index 3, how many jumps we need minimum. From there to reach index 4, how many jumps we need minimum. We can do this easily if we calculate how many jumps for index 1, how many for index 2, how many for index 3. Using these and a few other values, we can calculate how many for index 4. Otherwise, what we will need to do is calculate from 0 how we can go to 4, 1 how we can go to 4, 2 how we can go to 4, 3 how we can go to 4. In every possible combinations, that is what is called taking more time, which will create time limit exceeded error. That is what we don't want to do. That's our main aim. So, as stated, let's try this. So, first thing I'm going to point out, what about 0? How will I reach index 0? Index 0 will have a value 0. In minimum jump array, to reach index 0, you do not need any jumps. No jumps are required to reach index 0. That is why jumps for 0 is 0 itself. We are going to start with index 1. Remember, we are starting with index 1. How many jumps are required to reach index 1? This is what we need to calculate. To do this, I have a simple logic. Let me explain. So, to reach index 1, let us check. Can I reach index 1 from 0? See, if I want to reach index 1, I can reach it from any index before it. From any index before it. So, this loop, for me to search from index 1 to 5, if n is 6, take this assumption, guys, so that I can explain with the code easily. If n is 6, if number of elements are 6, I need to find minimum jumps required to reach 1, 2, 3, 4, 5. So I need a for loop here that starts with I equals 1, I less than n, I plus plus. Because I need to reach from 1 to 5, increasing 1 at a time. That is exactly what we're going to do. Now in this, if I want to reach index 1, I can reach from any index below 1. If I want to reach index 4, I can reach index 4 possibly from any index until 4. If this was 8, I could reach. If this was 10, I could reach. I could reach index I from any index j which is less than I. So I need one more loop here within this for j equals 0, because we can also reach from 0. That's why. Condition is j less than I and j plus plus. We can reach index I from any j before it. That is exactly what we are doing so far. So, with this clear, let us now try to figure out what is the exact logic we're going to use to find this. What is exact logic? I have one question from one of you. Peter has asked, can we use Python? Yes, you will be given multiple languages as option in digital. You can use C, C++, Java, Python, Perl. You can use any of this. That's completely up to you. The main reason I'm going for C in this case is because it does not require specific concepts like hash maps or anything like that from other languages. But if you're really confident in Python, feel free to use Python. There are no limitations as such. So here, now let's go within these two for loops. Now, when I is 1, observe this. When I is 1, I'm supposed to find minimum jumps required to reach index 1. To reach index 1, I can do it from any index before I. If this is I can reach this index from any index before I. So that's why we are using for j equals 0, j less than I, j plus plus. J equals 0, we'll start with j equals 0. Is j less than I? Yes, j is less than I. And then we need to check if we can reach here. Now to reach here, what I'm supposed to do here is just check. I'll just delete this, rewrite this. I'll check. Can I reach index 1 from index 0? How will I get to know if I can reach index 1 from index 0? From index 0, I can add 1. I can add 1. So if this is index is j. If index is j, I can reach up to j plus array of j. Or in our case, array is called, I've written it as p. Instead of p, we'll make it as array so that it's clear for us as input. So j plus, or you can also write it as input or anything, we've written it as array. J plus array of j is the maximum value we can reach. This is the thing we need to understand first. We can reach up to j plus array of j. That is, if I'm in index 0, I can reach up to 0 plus how many values? 1. I can reach up to 1. Similarly, if I'm in index 1, I can reach up to 3 values from 1. So 1 plus 3 I can reach up to. If this is my j value, I can reach up to j, that is 1, plus array of j, that is 3. That means I can reach up to index 4 from 1. That is exactly what it means. So in short, if I'm in an index j, I can reach up to j plus array of j. Now with this point clear, let's try figuring this out. Let's remember this formula. So when j is 0, can I reach index I? What is j plus array of j? J is 0. 0 plus array of j is 1. I can reach up to 1, and I value is exactly 1. So I can reach 1. So I can reach 1 from 0. So I will store 1 here. But before doing that, all these values must be infinity. All these values must be infinity, because you are trying to find minimum jumps. Minimum jumps. So first you'll replace infinity with 1. If there's any path, like initially you find 3 jumps, after that you find 2 jumps. Since 2 is lesser than 3, you're going to replace this 3 by 2. After that you will find 1 jump. Since 1 is less than 2, you'll replace it with 1. So you need to replace it with as minimum value as possible. To do that, your initial values everywhere here will be infinity. Let us just remember that. So let's assume all of these are infinite. So here, the first thing I'm doing, I can reach 1 from 0, because j plus array of j. From 0, I can do 1 jump. This indicates number of jumps. This indicates the index from where you can jump. I can jump 1 from 0. That means I can go to next value. I can reach index 1. So j plus array of j gives you till which index. Till which index can you move? This is what it will give you. So let us do the same. J plus array of j. 0 plus 1, I can reach till index 1. I can reach index 1 from 0. How many jumps are required to reach index 1 from 0? I'm reaching from 0. Remember, I am reaching from 0. So how many jumps are required? Only 1 jump. I need only 1 jump to reach. So I will replace this with 1. So I need only 1 jump to reach it. Done. Remember, why did I replace it with 1? Think about this. How many jumps do I need to go to 0? 0 jumps. From 0, I am calculating how many jumps to go to 1. From 0, I need only 1 jump to go to 1. Since from 0, I need only 1 jump to go to 1. To go to 0, I need no jumps. 0 jumps still here. From here, I need 1 jump. 0 plus 1 also. We only need 1 jump to go here. Now, once we go through more values of this, you will understand this program better. Now, don't worry if with this one example, with just this one I and j value, if it's a little confusing, do not worry. With more and more examples, you'll understand it much easier. So let's move I over to next value. Now when I is 2, now the condition is you can try to reach from index 0 also, you can try to reach from index 1 also. There will be 2 conditions. When I is 2 now, 2 is less than and true, will go here. So here comes condition j equals 0, j less than I value is 2. I can reach 2 from 0 also, I can reach 2 from 1 also, I can reach 2 from both the input values. Now in this case, how do we figure this out? Let's try this out. From here, from 1 from 0. Let's see if I can reach 2 from 0. Can I reach 2 from 0? What do you think? Can I reach 2 from 0? Depending on this formula, can I reach 2 from 0? Let's see if any of you can answer. Using the formula, not using anything else, only using the formula. Yes, we cannot reach. Obviously correct. We can't reach from 0. It's pretty clear. So, we get to know that from 0, 0 plus array of 0, 0 plus 1, you get basically 0 itself. Sorry, 1 itself. 0 plus 1, you basically get 1. So, you can go up to index 1 at maximum. You can't go ahead of that. Now, since you can't do that, let's skip it. Let's go to the next j value. From 1, can we reach index j? That is 2. Yes, we can. We can reach the same index from 1. So when we reach it from 1, because what is this j value? J value is 1. 1 plus what is array of j? From 1 I can go up to 3 jumps. Up to 3 values I can jump. 1, 2, 3. That is I can go up to 1 plus 3. That is j plus array of j. I can go up to 4. Now is that 4 coming under I? Can I reach I within that? J plus array of j, whatever I can reach, is it greater than equal to I? If j plus array of j, wherever I can reach, when j is 0, j plus array of j, the value I am reaching is less than I. 1 is less than I, so I cannot reach I. So the condition here is, if j plus array of j is less than I, that means I cannot reach I. If j plus array of j is greater than or equal to I, that means I can reach I. For example, when j is 0, 0 plus 1, I cannot reach 2. 0 plus 1 is 1. But when j is 1, 1 plus 3, I can reach up to 4. 2 belongs within that range. So I can reach even 2 here. So I can reach 2 from which number? I can reach 2 from index 1. So how can I reach? So since I know I can reach 2 from index 1, in recursive method, I would need to calculate how to reach 1 separately. But here we don't have to. We have already calculated how many jumps to reach 1. We need only 1 jump to reach 1. And from 1 we can go to 2. So from 1 to 2, there is 1 jump. That's clear. From 1 I can reach 2, 1 jump. So if I can reach from 1 to 2 in 1 jump, how many jumps do I need to go from 0? 0 to 1 is 1. 1 to 2, as we got to know, is 1. So we'll add it and get 2. So all that we are doing here is jumps required to move from 1 to 2 is 1. Since jumps required, I have one question. Why can't we use Python? You can. There's no condition like you can't use Python. You can. You surely can. Whichever programming language you are proficient in, you can use that. There is no condition that you can't use the common programming languages. You can do that. Whatever is language you are most comfortable with, you can do that. But I would always prefer C sometimes. Sometimes I prefer C because non-IT students will also find it a little easy. That's all. It's up to your choice. Whichever programming language you find most convenience with. Now, here, I can go from 1 to 2 with 1 jump. I already know to reach 1, I need 1 jump. So I will add 1 to it. That is, I can go from 1 to 2. So please note, I'll repeat this once. I already know to reach 1, I need 1 jump. And I got to know now that from 1, I can reach 2. That is also 1 jump. So this 1 jump I'll add to this 1 jump, which means I can reach from 0 to 2 in 2 jumps. Can I reach 0 to 2 in 2 jumps? 0 to 1, 1 to 2. I can reach in 2 jumps. That's the minimum number of jumps required to reach 2. Done. Now let's take the I value as 3 and try again. Now when I is 3, let's try now. Can I reach I from j equals 0? Because we know 0 plus array of 0, 0 plus 1 is only 1. It's less than I. Since it's less than I, we cannot reach it. Now let's try from 1. From 1 can I reach 3? I can. It's pretty clear. From 1 we can reach 3. From 1 I can reach 2, 3 or 4. I can reach all 3 of them. So from 1 I can reach 3. So since I can reach 3 from 1, let's try figure out how many jumps are required to reach 1. Please observe this very carefully. How many jumps are required to reach 1? That is 1. After 1 I can go directly to 3. That means total number of jumps required to reach 3 here are 2. Because from 0 to 1 I can go. From index 1 to index 3. I'm talking about indices. From 0 to 1 we can go. From 1 to 3 also we can go. That is how we got to know it is required as 3. Now remember, J value is 1 here. J value is currently 1. Now let's increase J to 2. When I increase J to 2, J is less than I. J is still less than I. Condition is true. When we go to J equals 2, now here we check that J is still less than I. Obviously true. So now we'll check here. Can we reach 3 from this index 2? From index 2 we can reach 3. Because J plus, how many jumps can we do from J? 8. So 2 plus 8, I can do jump up to index 10 as well. Because from 2, I can do 8 jumps. I can go up to index 10. So 3 is within the range of 10. J plus array of J is greater than or equal to I. It's greater than or equal to 3. That means I can jump to 3. So if I want to jump from 2 to 3, I need 1 jump. How many jumps do I need to get to 2? 2 jumps. Please observe this. To get to 2, I need 2 jumps. And to get from 2 to 3, I need 1 jump. So totally, if I want to go from 0 to 1, 1 to 2, and then 2 to 3, I'm taking 3 jumps. Is that 3 jumps minimum? Is that 3 jumps minimum, or is this 2 value minimum? This 2 is minimum. This is the minimum value for us. So we should not replace it with 3. We are supposed to find minimum jumps. If within this, if you have already found some jump value here in minimum jump of I, observe this. If minimum jump of I is lesser than, I'll just write this down. If minimum jump of I is lesser than minimum jump of J plus 1. What I'm saying is minimum jump of J as in, if you can reach from J to here, that is 1 jump. Take how many minimum jumps are required to reach J. To reach J is minimum jump of J. From J we know we need only 1 always. So add 1. If minimum jump of I, whatever this value is, it is less than minimum jump of J plus 1. It is less than whatever jump is required to go from 2 to 3. From 1 to 3, it is less. From 1 to 3, I can go from 1 jump, but from 2 to 3, I have to go 2 jumps here. True. So this will be more. So that is why we will not replace it. That's the basic idea. So the condition here is, all we need to know is, if the minimum jump of I, whatever this value is it lesser than, I can jump from 2 to 3 also. So to jump to 2, I have 2 jumps required. From 2 to 3, I need 1 jump. Since this value is lesser than that, then no need to update to this. If let's say for example this was 0, or let's say this was 4. If this was 4, then you are finding out that you can move from 2 to 3 as well. Assume you're finding out you can move from 2 to 3 as well. Minimum jump of J here. J is index 2. What is minimum jumps required to go to J? It is 2. You can jump from 2 to 3. Then the minimum jumps required to reach I, that is 3, is 2 plus 1, that is 3. That 3 value is less than 4. So then you will replace it with 3. This is how we exactly perform it. But currently we have 2 here. Let us leave it as it is. Now that this is done, when you increase J, J will now become 3. J is equal to I. So we stop this loop. We increase I value. Now we go to next index. So in the next index, let's do the same. Can I go from J equals 0? I cannot. I can't go from here. Can I go from J equals 1? From 1 can I reach 4? Yes, because 1 plus array of 1, J plus array of J, we can go up to 4. We can go to 4. So I can reach from 1. So how will I get to know how many steps to reach 4 from 1? From 0 to 1, we already know 1. From 1 to 4, 1. 1 plus 1, 2. So we're going to replace infinity always with the first digit we get, that is 2. After that, let's calculate from 2. I can go from 2 to 4, possible. But how many jumps? To go to 2, I need 2. Plus 1, I need 3. Is 3 lesser than 2? No. So no point in it. Then, can I try from 3? J equals 3. From 3, I can go to 4. But how many jumps again? 2 plus 1, that is 3. That is greater than this. So you can't do that. That's the end. Done. Now, since this is done, you can now increase I over to the next value to try to go to index 5. Now you can observe that once you are going through index 5, you are not going to calculate 0 to 1 or 0 to 2 or 0 to 3 or 0 to 4 or anything like that. You are only calculating directly everything to 5 only once. That is the exact point I was making when I said dynamic programming. Now we'll try again. From 0 to 5, not possible. Let's increase j. 1 to 5, not possible. Let's increase j. 2 to 5, possible. Since we can't jump from 2 to 5 because j plus array of j is greater than equal to I. Since we can go there, we will ensure that we can go from 2 to 5 in one jump. So if we can do that, how many jumps are required to go to 2 from 0? We have already stored here in minimum jump of j. Minimum jump of j. That we are going to add with 1. Minimum jump of j is 2. That 2 we are adding with 1. We are getting 3. Is 3 less than infinity? Yes, it is. So we can reach at 3. We can reach at minimum 3 jumps. That is 2 jumps to go to 2. Then from 2, 1 jump. Can we reach from the next value 3? When we increase j, we can't reach from here because 3 plus 1, we can only go to 4. Then can we reach from index 4? We can't. So no need to compare with the same. J is no longer less than I. We stop here. And this is how we get minimum jumps. Now if you get the last value here, if you observe the last value here, 3 is the minimum number of jumps required to move from index 0 until index 5. Let's see if that is correct or not. 3 is the minimum number of jumps. So from index 0, I can only do 1 jump, that is to index 1. From index 1, I can go here. This is first jump, this is second jump to here. And from here, I can go all the way here. That is third jump. So 3 jumps as minimum. Now the other case, what if you can't jump? What if this instead of 8 is 2? If it is 2, even here you can't jump, here you can't jump, here you can't jump. So it remains as infinity. When it remains as infinity, you can say that you cannot go to last index whatsoever and you end up returning 0. You end up printing 0 as the output. That is the entire program. Now, I hope everybody has understood this perfectly. You can leave a comment in live chat. I would prefer if you leave a comment in live chat, just let me know because you have gone through whole logic. You have understood. You can just state yes, no, anything. Just state according to you. So I will also get to completely understand the same. You can leave your comment in live chat. I'll continue to the next part, but you can leave the comment meanwhile. So let's go ahead from here. Now that we got to know this, let's try the coding part of this. So the coding part of this is, let's start here. Now, I need to send this array over to this minimum jumps. I need to send the array, and along with the array, I should also send 2 more values. I'll explain this. I'll explain this later on. I'll also send 2 more values. That is from where to where am I jumping. I don't need that in this case, but I'll just point this much out. So what is the array we need to send? Find minimum jumps. We're going to send array and number of elements. We're going to send both of it over there. Let's receive it. We can receive it as int star arr, or you can also receive it as int arr of brackets. That's completely up to you. And then we'll receive the number n as int n. I'm receiving with the same name. You can receive with the same name or different name, up to you. So from here, let us go on to the next part. Now let us start with the first part. Here I need 2 variables, I and j. Now, if you observe, we need one more array here. We need one more array called minimum jumps, which has the same length as our original array. So let's create that new array. Let's create that new array. Same code I'll copy here. But here, instead of array, I'll call it as int star minimum jumps. So minimum jumps required, I'm going to create an array. So initial value, I'll just point this out. Initial value of all elements in minimum jump should be infinity. Now we can't have infinity here. Instead of infinity, what you can do is store it with the maximum most value. Now in question, you generally will get constraints like 1 less than equal to n less than equal to 1000. They will give you something like up to 1000 elements can be given. Along with this, I'll just write it as constraints. Along with this, they may also give you for each element I, they can give you like 1 less than equal to I less than equal to something like 99,999 or something like that. In that case, if they give such a condition, you can take one value more than that. You can take one value more than that. If they don't give any condition, then use one more thing called hash include limits.h. Limits.h will store the maximum most value that can be stored. So what you can do here is for I equals 0, I less than n, I plus plus, each minimum value, each minimum jumps value will be stored with integer maximum. This integer maximum limit is stored in limits.h header file. Its value comes up to something like 21 lakhs, some value will come up. But for now, just remember, it will store the maximum most value possible. So if you want to print it, you can try printing it like here printf %d comma minimum jumps of 0. All of this will have the same value, that is int max. Let us try this just once. Let's compile code.c. So I have one question stating that int max is defined under limits.h. I've made one mistake here. It is include. I've made one spelling mistake. Let's try compiling again. So there's one little error. Sorry, this is min jumps of I. Please note one little error. So min jumps is an array. We need to ensure that each index value of that array is stored with integer maximum. That is what we are doing here. We have created a min jump array with the same length as our original array, and each value from 0 to n minus 1 we are storing with int max, that is infinity, as we expected. Now let's try. Let's compile, let's run. Okay, I need to enter values. Let's give 3 some value. So now you can see this is the maximum element, maximum integer element that can be stored. Now there's one thing that we still are yet to do. We have not read numbers. We have only read n value. We haven't read the integer numbers yet. Let us read the integer numbers as well. So for I equals 0, I less than n, I plus plus, we'll just use scanf %d ampersand arr of I, array of I. So this for this purpose we need one more variable that will take it as I. So once done, let's go on to the next part. Now here, pretty simple. We don't need to print this anymore. We got to know what is max value. We consider this as infinity in our words. Now let's go on for the next part. Now the next part is pretty simple. We have already done the next part earlier. Now one thing I'll tell you, we need to write a specific condition. We need to write one specific condition. What if n itself is 0? If user enters n as 0, what are you supposed to do? If you don't do anything, you will get an error. If you try this, you will only get to understand this when you try different test cases. In interviews, test cases are important. You need to try as many test cases as possible. So that's why we're going to use this as a test case for n equals 0. So if n is equal to 0, we will return 0. 0 means you can't find the last element. If this is one hidden test case and you miss it out, you're going to lose out on important valuable marks to ensure that you go ahead of anyone else. Now, One more condition we need to put up also is if array of 0 is equal to 0, even then we need to return 0. Why am I doing this? Think about this. If this value is 0, can I move to last index from first index? My question is about moving to last index from first index. If our first index itself is 0, no matter what I do, I will not be able to move to last index. Because from first index I can't move anywhere. That means I can't move to any of this. It doesn't matter at all. So that is why the second condition we give is if array of 0 is also 0, we return 0. Or we can combine them as if n equals 0 or array of 0 is equal to 0, return 0. That's it. This is our first couple of test case. Now after this, now we can write the code. So now you can write the code here to find minimum jumps. This you can write here as test cases. Now let's start. So first thing, for I equals 1, I less than n I plus plus. Why I equals 1 I less than n I plus plus? Because I'm supposed to find minimum jumps from index 1 to 5. Index 0 we know minimum jump is 0. Minimum jump to go from index 0 to 0 is 0 itself. So we know that. So one thing you also need to do before this is ensure that minimum jumps of 0 is equal to 0. This is one thing you need to ensure. So we'll do that here. Because from 0 you don't need to go anywhere to get to the same. So we'll make minimum jumps of 0 as 0. To go from 0 to 0, it's the same thing. Now let's start with this. Now with each of these values, let's start calculating all of this. Now one thing you can do, since you're making minimum jumps of I equals int max here, instead of making it here, you can write it as the first line of this for loop itself. Before calculating, before finding, make it infinity, then find it. This will ensure that you don't need to have multiple for loops also. You can even remove this. So this is to ensure that infinity values. Now let's start with the next part. So if I'm supposed to find minimum jumps to reach 5, I need to find minimum jumps to reach 5 from 0 until 4. That is from j equals 0 until j less than I. So let's start that condition for j equals 0, j less than I, j plus plus. Now remember, I'll just write the comment here. This is for each minimum jump index. This is for each array index. So for each array index, we're going to check if we can go from that array index. For each array index, we're going to check if we can go from that array index over to our I. So to check that, as repeated, as stated earlier, if I want to move from 2 to 5, how will I check? I'll add j with array of j. Whatever j with array of value I get, 2 plus 8 is 10. That 10 value should be greater than or equal to I value where I'm supposed to go. If I want to go to 5 from 3, 3 plus 1 is less than 5. I can't go to 5. But 2 plus 8 is greater than or equal to 5. So the condition here is if simple array of j plus j greater than equal to I. That is, if you can reach or cross the index I, then what do we do? If we can reach or cross index of I from j, if I can reach or cross index of I from j, that means I can reach from j to I in one jump. In one jump I can reach j to I. But how am I reaching from 0? To know how am I reaching from 0, minimum jump from whatever is there, from 0 to j to reach, that is here. This is minimum jump of j. This is the minimum jump of j. This I'm adding with 1. So minimum jumps required to reach index 2 is 2. For this I'm adding 1, so I can reach minimum jump of I. So the same thing we're going to write here. If again, condition, you should not always replace it. You should check if minimum jump of I or minimum jump of j plus 1. Here, if I'm able to reach it in one step, should I use 2 plus 1 as 3? I shouldn't. I should not do that. I should only do it when minimum jump value here is greater than, minimum jump of I is greater than minimum jump of j plus 1. Minimum jump of j is 2, 2 plus 1 is 3. 3 is lesser than infinity, so I can replace it with 3 now. That's the idea. So what we're going to do here is, if minimum jump of I, please observe, minimum jump of I, or you can also start with minimum jump of j plus 1 lesser than, minimum jump of j plus 1 lesser than minimum jump of I. If minimum jump of I, let's say, is infinity, and minimum jump of j plus 1, whatever you get, this is infinity, and j plus 1, what you get is 2 plus 1, that is 3. 3 is lesser than, minimum jump of j plus 1 is lesser than minimum jump of I. So replace minimum jump of I with minimum jump of j plus 1. So if that is the case, we will replace minimum jump of I. Sorry, I made one mistake, guys. This is all minimum jumps, because everywhere I've used minimum jumps. Let's please ensure to replace that, because we don't want errors at the end. I think we have made one more problem. Yeah, no other problems. That's it. Perfect. So minimum jumps of I is equal to minimum jumps of j, and we are adding 1 to it. That's it. So this is exactly what we're doing. Now, after doing this, basically, right now I'll just point out and repeat this. If array of j plus j value, whatever is there, is greater than or equal to I, we do this. Now, there may be a couple of errors we may expect. I'll explain what are the errors we may expect in this. I'll explain that in detail in just a while. I'll ensure to do that. So with this, now let's go on to the next part, slightly next part. So once we got to know this simple logic, now this keeps on performing. This will keep on performing till the end. After this is done till the end, all I need to do is check what is minimum jump of n minus 1. If n is 6, minimum jump of n minus 1, whatever is here, this is what I have to print. If I get this correctly, then I got to know how many jumps are required minimum to get to the last index. Let us try once by printing %d/n, comma, minimum jumps of n minus 1. Let's see if it works. So I've printed it within j loop. I'm supposed to print it outside j loop, so it only prints once. All right, let's try this. And our input is, we'll enter the same input as here. Let's see if it works. We'll see if it works, or if it doesn't work, we'll see what else we need to change. So let's compile. So since we've modified the program, let's compile. I'm having one statement saying return 0. Okay, I'm not supposed to return 0. Instead, I'm supposed to print 0. So because this is a void, I'm supposed to print here, not return to main function. So I'll just print 0 instead here for this. Now let us give this a try. We got to solve our little error also. Let's run this. I'll give 6 as the values. Let's look at the 6 values we have here. That is 138106. So 138106. Now if you observe, 3 jumps are required minimum to reach the last index. So this is exactly how you can solve it. I have received one question which I have observed from iOS stating, will there be only coding questions or MCQs too? Here you can expect only coding. You have 60 minutes to solve these kind of coding questions. You can expect only these. So This is how you can get to know that minimum jumps required is 3. Now another question that they may ask, I'll give this one part as a possible solution for you. I'll give this one little part as a small assignment for you. Another question they may ask is, write the path to reach that index. Write the path to reach that index. So how are you gonna write the path? From 0 to where should I reach, from where to where should I reach, and so on. So the idea here is, to reach 5, where are you going? From, you're jumping 3, from where? You may have forgotten, you may not know. So the idea here is, to know that you need to create one more array. If they ask you to write the path, you need to create one more separate array called something like minimum jump value or minimum jump array or something like this. I'll just create that very short and simple and easy program to explain. We'll take one more thing here called minimum jump index. I'll call this as minimum jump index. Now every time we do this, along with this, I'll update one more value here. I'm going to update another value, and this is the particular value I'm going to update. Now if I'm moving from j to here, for example, please observe, if I'm moving from 0 to 1, I know that I'm moving from j which is 0 to I. I know I'm moving from j to I. So I will write that index value j here. If I'm moving from 2 to 5 in one shot, if I'm moving from 2 to 5 here, I know I'm moving from 2, which is the j value. Since I know I'm moving from this j value, you can write that j value here as 2. That is how you're going to write. So you can get to know, to reach 5 you're going from 2, and you go to reach 2 you're going from 1. If you go to 1, to reach 1 you're going from 0. That is how you get to know. So from here you're reaching here, from here you're reaching here, from here you're reaching here. So in short, anytime you're updating to minimum jump, in minimum jump array, you just need to update which index are you jumping from. If you're jumping from index 0 to reach 1, update that 0, which is j, over in this array. If you're reaching from 1 to 2, 1 is the j value, so update the j value in this array. You'll get this array. Once you get this array, you will finally need to go from last index. From last index, whatever you get is 2. So you need to go to index 2. Index 2 you're reaching from 1, so go to index 1. Index 1 you're reaching from 0, so 0, you're no point in it. So once you get to 0, then you have to print this path 0 to 1 to 2. This one little thing I will give it to you as a small guess assignment or question. Anyone who can solve it can submit the code as well. So I'll give you a clue. Just create one more array, and after creating the array, write your code here where minimum jumps index is equal to j. That's all you need to write. If you do this, you'll be able to find the same thing. I'll write this as a comment line as well for your reference. Once you've done this, at the end, all you need to do is print path using a logic. So the logic here is, you need to go to the last index. You always need to go to last index. Which index are you going to last from? From index 2. Go to 2. Here you are going to 1. Go to 1. Here you are getting 0. Store this separately. Print it in the reverse order. That's it. 0 to 1 to 2. That's it. That is what you need to do. So this one thing, I'll ask you to try it out, but I hope everyone has understood the major logic of this program. This question can be asked in many ways, and it's called find jumps program. So I hope everyone had a good time. I request everyone to just let me know if you're able to go through it, easily able to understand it. I'll share the whole code in the comments right away, so please wait up. Also followed by this, if you want to go through more programs, if you want to go through more questions, if you want to go through more and more aptitude, technical as well as verbal content, please like, subscribe our channel and go through all our videos. We've got so many videos throughout our channel which you can find to be very useful for your interviews. And if you're interested in going through our complete training to get you to be placed, to ensure that you're placed, 100+ hours of entire training in coding, technical, verbal and aptitude, go to the description, check us out, contact us anytime. So thank you for the time. I hope you guys had a good time. Just you guys can let me know through your chat, live chat, how you felt about this session, and or comment as well. We'll catch up in one of our next sessions, and I'll share the code for this in a while. Thank you guys.